Hello, everyone, and welcome to the video on Unit 4, Lesson 5. We have spent the last couple of class periods working through these different examples, but for most classes, we've only gotten through slides 1 through 3. There are some students in each cohort or group that have gone beyond that, but for the most part, most of us have not gotten beyond slide 3. And so because of that, I wanted to spend most of this video focused on slides 4, 5, 6, and 7. And so what I'm going to do is show very briefly a couple of the answers that you should have on slide 1, on slide 2, and slide 3, so that you can make sure you're on the right track. And then I'm going to skip all the way down to slide 6 and show what that work would look like. And that will then help you with slides 4, 5, and 7, since those are all very similar questions. So let's begin. On slide 1, we talked about how the tape diagram needed to be either mice to combined rodents, so 3 boxes to 5 boxes, in which case you would need to delete these red boxes that I marked red on mine, so that it shows 3 to 5. Or you can do mice to moles, in which case you need to delete 3 boxes for mice and 4 for moles, so that the ratio shows 3 to 2, which is what the numbers were in the original story problem. The next thing is we need to divide the 100 by the 5 boxes of rodents. So regardless of which tape diagram you use, there are 5 boxes for the combined rodents. Either they are shown as an actual section in your tape diagram, or they're the combination of all of the other boxes in the other version. And so you'll divide 100 by 5. You should end up with 20, which means that 20 is the number that goes in every white box and helps you to find the 2 total numbers, the total of mice and the total of rodents, or the total of mice and the total of moles, which, if you add those 2 together, is also 100. The final piece is that the ratio 3 to 5 is equal to the number that you found in the green compared to 100. So you would type in the number you got in the green, the colon, and then 100 in the second box. And that's also the one you would use for your answer. I hope that's helpful. If not, please make sure you look back at old resources or reach out. For slide 2, I'm just going to talk quickly about part B. There was a typo. It said how many 1/2 miles are in 12 minutes. It should say 12 miles. I apologize for that if that was confusing at all. What this means is that we're trying to figure out what 12 divided by 1/2 is. And so your work here should look like 12 divided by 1/2. I'm just going to highlight that so you can see it more clearly on the video. And then we would change that into a multiplication problem by saying 12, the dividend, multiplied by the inverse or flipping over of the fraction. So 2 over 1. That would be your second expression. This is the one that we use to solve with just numbers. And the third expression should be saying that those 2 things are equal. Actually, I'll highlight these a different color. So you would say that the yellow part is equal to the green part. But they both help us to solve the problem in different ways, which means that they are equal to each other. Okay. The last pieces are the model, which would have 12 separate holes, all of them shaded, and then each of them broken into halves. So 2 pieces for each one. And then you would count every single piece because you're dividing by 1/2, which means you're looking for how many sets of 1/2 there are, how many groups of 1/2. You should end up with 24. And so your final answer here would be 24 1/2 miles in 12 miles. And that's what you should get from both the calculation on your picture and the model that shows the 12 different holes cut into pieces, shaded, and counting the pieces. All right, I'm going to jump on to slide 3 now. So for slide 3, hopefully you've seen the example completed in class, and you've also seen potentially part B done with you or for you. So I'm going to look at part A. So part A says how many 2/3 cups are in 6 cups. So that means that 6 is our dividend and 2/3 is our divisor. So then the multiplication is 6 times 3 over 2, 3/2. Then I would say that those two things are equal. So I'm just going to highlight them really quickly so that you can see the answers on the video. And you would then put the yellow part here and the green part here, saying that whatever you get from the division on the picture is the same as the multiplication that you would get by 6 times 3 over 2. Your final answer should be 9. So if you did not get 9 groups, if you didn't circle 2 at a time on the picture, if you didn't get 9 full circles, then you might have made a mistake somewhere along the way. So make sure you look at your examples for EX and for part B to support you on that. All right, I'm going to pause the sharing because this next part is going to be more involved. Okay, in slide 6, which is similar to slide 4 and also similar to slides 5 and 7 in terms of what I'm asking you to do, we are looking at the same types of diagrams, except that the calculations that go along with it are different. So the diagrams, they are the same for the most part, but the calculations are different. What you're going to do is you're going to copy the diagram that you see for the most part, and you're going to show me a finished product down in the bottom. So you're going to insert an image that has just the model part. And then the calculations you'll do with the fractions that are here. So for part A, that would be 5 circles, all of them shaded lightly. Don't do a really dark shading. It makes it harder to break them up and to label them. And then you're going to break them up into fourths. And that's because in this problem, there are 5 whole pizzas, and we're seeing how many 1/4 slices are in those 5 pizzas. And so we're going to break each of the 5 holes into 4 pieces and count the pieces all the way to the end. You'll see that I've already started the counting. You don't have to put the numbers exactly where I put them. You could count the other way around. You could cut it with a plus sign instead of a multiplication sign. You could also put the labels around the outside, like what I'm showing with these highlighted numbers. So you don't have to put them inside if that's harder for you. We just need to make sure that we're counting every piece very clearly. So by the end, you should end up with whatever number we get from the calculations. So let's go through what the calculations would look like. It says number of pizzas. Well, in the word problem, there are 5 pizzas, so that must be 5. I also see that this is green, and the highlighting in the story is green, so that matches. Blue fractions always represent the whole. And so if I look in one of these holes, I see that it's shaded completely, and that it's broken into 4 pieces. So that's the fraction 4/4. And so we're not doing the division yet. What we're doing is we're preparing our whole number to be ready for the division. 5 times 4/4 is 20/4, which is the improper fraction that represents all of the slices that are in these pizzas. So 20/4. I'm going to copy that again. And then I'm going to divide by the size of one slice. Well, one slice is 1/4 of the pizza. So I'm dividing 20/4 by 1/4. When I divide 4 by 4, that's a 1. And when I divide 20 by 1, that's how many ones it takes to get to 20, 20 of them. So my answer so far, the fraction for the number of slices is 20/1. And we know that if you have an improper fraction answer, you can count by the denominator to get to the numerator. So how many ones does it take to get to 20? And that's 20. 1 goes into 20 times. So then my answer here is 20/1/4. I'm just going to highlight that yellow so it stands out in my work here. You don't need to do the highlighting. So hopefully that makes sense. If it doesn't, please check in with me or look at your previous examples. But basically, we are taking the whole number for the pizzas. We're multiplying it by what a whole fraction looks like, just like what we did last week. The improper fraction that we're given, or that we've created now from that, we're going to divide by the fraction that's in the actual word problem, 1/4. And when we divide, we get 20 over 1, which is 20 whole pieces. What that means is that if you were to count all of the little pieces, your last number should be a 20, and you could put a star by that and then insert the image. So let's talk about part B now. If you need to pause, please pause the video so you can process this, go back, rewatch it. For part B, we have 4 bars, like maybe granola bars or chocolate bars, something that has bars. And we're looking for how many 4/3 pieces we can get from that. Imagine this as like sharing it with a friend. You have 4 chocolate bars and you're sharing 4/3 with each friend. Your goal is to figure out how many friends you can share it with. What's interesting about this particular problem is that 4/3 is more than a whole. So your pieces are actually more than a full bar. So you're giving a full bar and a little bit more to each person, which also means that your answer is going to be less than what you started with because you're giving up more than a whole for each person. All right, so let's go through the work. You'll hopefully notice that I've drawn 4 boxes. Each of them are broken into thirds, and that's because of the fraction. 4/3 means that we're looking at thirds or pieces of 3 in each hole. You also might notice that there's a really, really light shading for the first 4, a darker shading for the next 4, and a light shading for the last 4. This is not required. This is totally optional. For me visually, it's actually easier for me to kind of alternate between 2 different kinds of shadings so that it's easy for me to create those groups. But it's something that you have to do planning ahead. So you are going to shade all of it, but you could then like darkly shade or with a different color shade every other group. And then I've put these little brackets around them to also show the group. So the first group is 1 piece of 4. The next group is the second piece. So now we're at 2 pieces of 4. And that third bracket would need to have the label 3 pieces because there are now 3 pieces that you're giving, or 3 people that are getting pieces of these chocolate bars. So our answer to this problem is 3. And I'm going to put that here. So my answer is 3 4/3 pieces in the 4 bars, which is kind of strange, but it makes sense in what I said before. You're sharing 4 things and you're giving more than a whole to each person, so you're going to end up giving it to less people than the number of bars. So let's look at the calculations, and hopefully this also helps us. The number of bars, 4, and it's green, so it should match. A whole fraction. Well, if I look at one picture, there's 3 slices, and so a whole would be 3 out of 3. Oops, sorry, made some mistakes. 3 out of 3. So then when I multiply, I should get 12/3. 12/3 represents all of the pieces before you've split them into the groups. 12/3 is the improper fraction for the bars little pieces. And then that means that 12/3 is going to be divided by the divisor in our problem. Our divisor is where it says how many 4/3 pieces. So I'm going to put 4/3 right here. And then when I divide straight across, I get 3 on the top, 1 on the bottom. And anytime I have a 1 on the bottom, I can just count by ones to get to the top. So 1, 2, 3, my answer is 3. So that confirms that it's correct. For the diagram, if you would prefer to do circles around the groups instead of these little brackets, that's totally okay. But if you like the way that the brackets are kind of a neater way of showing the groups, then you can do the brackets as well. Just make sure that you have a complete image with all of the pieces shaded, with the groups by 4s, but the holes are by 3s, and then the labels, 1, 2, 3. The word pieces is really referring back to what the original problem said, where it's saying 4/3 pieces, meaning the pieces that you give to a friend are 4/3 of a bar. Please let me know if this was helpful for you or if you need any other support. And hopefully this will help you to complete slides 4, 5, and 7. You can copy whatever we've done here as your slide 6. Have a great day, and I will see you the next time in class.